Hey, welcome back! We assembled the output ports board for the Mark-8 reproduction computer in the previous video. We'll continue with the next board in the order, which is the memory board. This board is more complex than most of the other boards, mostly due to the number of ICs that need to be installed, but it's still fairly straightforward. Just a reminder, if you would like to follow along by building your very own Mark-8 mini computer, the PCBs are still available for sale at kalinchuk.com. We'll continue referencing page 4 of the Mark-8 construction manual for the list of parts, and also page 39 for the parts layout. Additionally, we will reference the bug sheet that was released a little after the Mark-8 was introduced in the Radio Electronics magazine. It's marked as page 46. The previous two boards we assembled did not contain any bugs, but the memory board does. Point number 4 of this sheet states that the 8 holes at the top of the memory board that cross the ground line on the other side of the board should not be connected through the board. We can check for continuity using a simple multimeter. To fix this issue, we will need to drill the holes out to remove the vias. I will use a number 60 or 1mm drill bit, which is slightly larger than the hole, to do this. Not all drills support small bits, so I will use this chuck designed to hold smaller bits. We can verify that the upper lines are no longer connected to ground with a simple multimeter. I think this issue will be fixed in newer boards, but if you have a set and you're unsure if you have a newer board, be sure to verify with the multimeter. Let's start with the assembly. We will install resistors first. Make sure to follow the parts list and parts layout sheet when installing these resistors to know where each one goes. Let's move on to the IC sockets. Again, you can install the ICs directly onto the board in this step instead of installing the sockets if you prefer, although having sockets to change out bad memory is a good idea. Pin 1 is usually designated with a dot on the board, but if the dot is not present, refer to the parts layout sheet. Next, we can install the connectors. The top connector is an 8-pit Molex, and the bottom connector is comprised of 3 10-position Molex and 1 11-position Molex connectors, as with other boards. We also have a 2-position Molex connector on the top right. I'll include a link to these connectors in the description. Finally, the 3 0.1 microfarad ceramics can be installed in their respective positions. One more thing. This board also requires a few jumpers. There's one jumper between IC33 and IC34. Since this is the first and only memory board, we will also need the jumper 0 here and the 8 positions here. Additionally, we will need to select the correct memory block by connecting A to 0, B to 1, C to 2, and D to 3. The Mark-8 is designed to accept multiple memory boards that could be linked together, and these jumpers are used to configure each board. You can find more information about this on page 6 of the Mark-8 construction manual. Now is a good time to give the board a good wash. After that, we can start with the IC installation. IC33 is 7442 and IC34 is 7400. The remaining ICs are designated for the memory circuits. I won't install the full set of them in this video, but at least 8 of them are required for the computer to function, so we'll go ahead and install 8 1101 memory ICs into IC1 through IC8. The board is now ready for testing. As before, I will hook it up to my other Mark-8 computer that I built in previous videos. To verify the functionality of the board, I will deposit data into a few memory locations and then examine to see if the data that was deposited is still there. I'll also run a simple program to verify the connection between CPU and memory. Everything looks great. We have finished assembling half of the board so far. We'll continue with the next board in the series in the following video. Thank you for watching, and don't forget to like and subscribe, and be on a lookout for the next video. Bye bye.